How do you define force? How do you say forces?
What do you mean? Sorry.
What is a force?
Force is a push or a pull.
Okay. And what is displacement? And what is the difference between displacement and distance?
Displacement and distance. Distance also. Distance is basically a traveling from A to B.
Okay.
Displacement also considers the magnitude. No, magnitude and direction.
Which has the magnitude and direction, distance or displacement?
Displacement.
Good. Okay.
It's a vector quantity.
Vector quantity. Good. Okay. Let's say this is a point A and this is
Yeah.
point B. And let's say a person travels this way. Let's say this is 4 meters, 5 meters, 6 meters, and 7 meters. Can you tell me what is the distance and what is the displacement from A to B?
Displacement is 10. Distance is yeah, all of them added together.
Good. Okay. And let's say he returns back to A. So what is the displacement?
0 is the
Good.
displacement and
Okay. 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 Now tell me what is work done?
work done is the energy transferred, right? Energy
Okay.
transferred from one body to another.
Then what is the difference between the work and energy?
Um, work done. Yeah, I don't know. I'm not
Okay.
sure.
Okay. What is the equation for work?
The equation for wait, I actually wrote down. It depends actually. There's a few,
Okay.
right? Work half m. Which one?
Have you studied about the
Oh
scalar and
yeah.
vector products?
Fs cos.
Yeah.
Fs cos theta.
Okay. And what is theta here?
Theta is the angle for which direction it's going and which way the force is going. If you know what
Okay.
I mean.
So yeah, basically it's the angle between the force acting and the displacement of the body, right?
Yeah.
Okay.
Yeah.
So let's say there is an object,
Yes.
and let's say I'm applying a force of 10 newtons on this object,
Yes.
and let's say it moves a distance of 5 meters. So what will be the work done?
0.
How?
Because it's going horizontal. There's no angle.
Okay. So you're saying the angle is 0, isn't it?
Yes, because you're pushing to
Yeah,
one
you're right.
side.
The force is in this direction and the displacement is also in this direction. So the angle between the force and displacement is 0. You are right until this, but why are you saying the work done will be 0?
Um, because
I mean, think practically. You are applying a force and the object is moving, right? So there is some work going on. How can you say the work is 0? I mean, if you see the equation carefully, the angle is
yeah.
0. If you put 0
Yeah.
here, cos 0 is not 0, is
Oh,
it?
cos 0 is not 0.
Okay, so
Yeah,
cos 0
cos
is 1,
0
isn't it?
is yeah
Yeah.
1, so it's
So the
just
force
Fs.
is 10 times the displacement 5 times cos 0, 1. So the work done will be 50. And what are the units of work done?
It's 50.
What are the
I'm sorry.
units? What are the units?
It. How do I not know? It's Newton. Is it in joules?
Yeah, it is in joules or else can you say
Newtons
any?
per meter.
Is it newtons per meter?
Newtons meter, like
Yeah.
if you multiply
See,
them
if you
together.
don't know the units of any parameter and if you know the equation, you can directly find because it is force times displacement, right? The
Yeah.
unit of force is Newton, and displacement is meter. So Newton meter, that's it. Okay. So see, here the work is done, isn't it? And if
Yes.
the object is moving, what kind of energy does the object possess?
Frictional force and
No, I'm not talking about the
what was
force.
that?
Here
Yeah.
you're applying some force and the object is moving. right? And we are saying in
Yeah.
this process of 10 Newton applied and 5 meter distance moved, work done was 50 Newton meters, right? So, like while the object is moving, what is the energy the object possesses? Have you learned
Energy.
about different kind of energies?
Yeah, I did.
Okay,
But then it's in kinetic energy, right?
good. It's kinetic energy, right? So, and how do you find the kinetic energy? What's the equation for kinetic energy?
Um, half mv squared.
Half mv square. Good. Okay. So here, let's say you know the mass of the object. Let's say it is 2 kilograms or something. So if you know the mass of the object, you can find the acceleration with which the object will move under this force, right?
Yes.
Okay. And if you know the acceleration, you can find the velocities as well,
Yes.
right? So,
Velocity by Subat?
I mean, you know the displacement, you know the acceleration. Let's
Yeah.
say they gave you the time it take to reach the final point. So all of this will help you to find the velocity, like final velocity and initial velocity. So now, whatever the force you're applying, it is doing some work, right? And how is that work expressed as? It is expressed as in terms of some energy. In this case, the work done is being translated to kinetic energy, which is making the object move. So the work and energy terms can be used interchangeably, but both are different. Okay. So the work
Okay.
is expressed in terms of some energy. Okay. That's the
Okay.
main
Yeah.
difference. And have you studied about power?
Yes, I have.
Okay. So what is power?
Um, Power is the rate at which energy is performed.
Good. So the definition is correct. Do you understand what it means?
So how fast the
Good.
energy is performed.
That's it. So like, for example, let's say there is an object and I'm applying a force of 10 newtons and I'm applying this force for a duration of 5 seconds. Like it takes 5 seconds to apply the 10 newtons of force. And in another case, I am applying the same force, but I'm applying it very fast, just in, let's say, 1 second. Okay. Here, under both these instances, the object might experience same difference in the energies. Like initially, it might be at rest because of this much amount of force, it might acquire certain energy, and the same will be acquired here as well. But the power is measuring at what rate that energy is going to transfer. Okay, so in this case, the power will be less because it takes 5 seconds for the transfer of same energy. But here, you are just using 1 second. Like let's say, just take a random example. Like let's say you are hitting a wall. Okay, so you can hit the wall with the same speed slowly, or you can just hit it at the time immediately with a faster, like in a lesser time. So you are applying more power when you are hitting it fast, right?
Yes.
Okay.
Yeah.
Okay, so I think you understand what is the difference between work, energy, and power, right?
Yeah. Work is. Wait, I still don't really understand the difference between energy and work.
Okay.
Like
Whatever the
exactly.
work is done, the work done will be expressed in the form of energy.
Yes.
Okay. For example, let's say there is an object resting on the ground. Okay. And now let's say I am taking that object and placing it at the top of that building.
Yes.
Okay. So, okay. Now tell me, what is the potential energy of this object when it is on the ground?
0.
0. Let's say the object's mass is m. Okay. So tell me, if I want to place this object, let's say the height of the building is h. If I want to place this object at the top, what is the amount of force with which I have to lift this?
Force.
So how much
Um.
force should I apply?
So F. I mean, it's
Whatever its weight is, I need to apply the equivalent force to lift it, right?
yeah.
And what is the weight?
Mg.
Good. So it's clear, right? I have to apply a force of mg to at least a force of mg to lift it upward, right?
Yeah.
And now let's say I have to take it from the ground to a building of height h. So I'm doing some work to do this. So what
Yes.
is work?
You'd.
Force times displacement times cos theta, right?
Yeah.
So what is the force with which I am pulling it up? Mg. And
Mg.
how much displacement I'm moving it from 0
H.
to height h. So mg.